So stay tuned till the end of this video, because throughout the video, we will not only discuss how to solve this problem, but we also discuss about the physical significance. So let's come to the physical significance first. So the problem statement mentions to calculate the residue. Now residue is linked with singularity. So with the definition of singularity, it means singularity is a point where the function tends to infinity. So here you can think of a tornado. The center of the tornado is extremely violent. And as you move closer to the centroid, this particular the tornado becomes extremely violent. And that is what the singularity actually means. Likewise, the residue measures the rotational strength of this function around this singularity point. So now imagine as you come closer and closer to the tornado and you walk in small circles. If the tornado is weak, so the rotational strength is low. And if the tornado is quite strong, the rotational power is too high. And that's exactly what residue tells you. So it defines how strong the spinning effect is. Now, why are we looking at z equal to 0 for this particular problem? That is because at z equal to 0, the denominator becomes 0 and thus the function tends to infinity. And that is where your tornado actually exists, which is nothing but the singularity of the problem exists. And the total rotational strength of the function is given by this expression. Now coming to the thought process to solve the problem. So identify where the denominator becomes 0. In this case, for z equal to 0, the denominator is 0. Likewise, for the numerator, when we put z equal to 0, we get this value. So here we have something upon 0. That is numerator not equal to 0, but denominator is 0. So something upon 0. So this is a case of simple pole. And when it's a simple pole, this is how you calculate the residue. And given that if z equal to a is a pole of order n, then this is the expression to calculate the residue. Now the step-by-step solution. So the residue of f of z at pole z equal to a and here a is equal to 0. So this is how your function becomes. So this is the term that we have added, provided that we also apply the limits. And by solving this expression, you land up at this value, that is 1. So coming to the practical applications, now you see till here we have solved the entire problem, but where exactly, apart from tornado, what else can you apply the concept? So think of a washing machine wherein you put a lot of clothes, and when the drum of this washing machine spins, so at certain speeds the vibration becomes very strong. And why does it cause so much of amplitude? It is because the speed matches the natural frequency. But how violently will this shake? Now that depends upon the system response strength. And that strength is nothing but the residue that we just saw. And that is actually one of the practical engineering applications. Thank you so much.